switch statements, switch and case statements. Python does not provide those. Java does, so does C++.
As I remember, when we're making those long if statement sections, they kept telling me switch it to, and change it to switch it.
Yeah, the editors will NetBeans in particular is really happy to convert things from one syntax to another. And sometimes their changes look completely alien and horrible because they're taking advantage of something called functional programming. But yeah, if you have a long series of if statements, it wants to make a switch out of it, it's a cool thing to let it do. All right, so chapter 4, making decisions. Relational operators. Relational operators compare two values and, based on their operands, return a true or false. There are also binary operators requiring two operands. And we've been using these since grade school. Greater than, less than, that kind of thing. Which way is the alligator mouth pointing? It's pointing towards the A or the B. Which one's greater than the other one? I don't know why we were taught that, but we know what these mean pretty much. I just want to make absolutely sure that we understand that we have # equals, which means not equal to, and that a specific syntax that you may have taken advantage of in Python is not available to you. In Python, you could do this: if not A equals B. You can't do that because not is not available to you as a keyword. That is not a keyword available to you in Java. If you want, you can do that. I would strongly prefer you to do this: if A's not equal to B, right? Just, that makes my brain happier to look at. Here's something else you cannot do: if A less than or equal to greater than B. No, can't do that. Syntax error. Instead, you use not equal. How about if you did this? If A is less than 3, no, wait. What if you wanted to see if something was between 32 and 212? So if 32 is less than T is less than 212, is that good syntax? Looks great. No, it's not. And the reason why is because these are binary operands. They're processed left to right, so the first thing that it does is it compares to see if 32 is less than T. So that evaluates to either true or false. And then, is true less than 212? And that's a what the what? That doesn't mean anything. So you cannot write it like that. Instead, you have to write it something like this: if 32 is less than T and T is less than 212. Or you have to nest some ifs together. But that would be the preferred way to do it, where ampersand means and two vertical pipes means or. You can assign the result of such an expression to a Boolean variable. Or if you store it in an int, it's going to put a 0 for false or 1 or true. Never mix up your single equals and your double equals, because the C compiler will compile this code, but it will mess you up. What if you do this? Age is equal to 32. And then if age equals 20, we would have to put that in parentheses to get that to work. Then C out, hooray. For whatever purposes. Looks like good code, but it's not. What would it do? It's a single equal sign. That's the assignment operator. It'll copy 20 and erase the value of age, replacing it with 20. And if age is now not equal to 0, it'll print hooray, but if it is equal to 0, it won't print hooray. So 99.999, all the for every age except for 0, it would print hooray, and not only that, it would wipe out your data. So never use single equal for comparisons. The compiler will probably give you a warning about that, but in C and C++, it doesn't consider a syntax error, so it's not going to create an error. Java and Python it will, I believe. So don't mix up equal and equal equal. One is the assignment operator. Second one is the equality operator. Let's get a better name for it. What did they call it in the slide? Equal to. Okay, fine. So the if statement. We know the way if statements work. There's an if, and then there's a Boolean condition, an expression that evaluates the true or false. And if that's true, it goes ahead and does it. Now C and C++ are a little bit funny in that you can put something inside the if statement other than a true or false expression. You could do this. X is equal to 1, and then if X. It'll go ahead and do what's ever in here. This will work if you wanted to print out hello or for whatever purposes. This would work because if you give C or C++ an integer value in there, it just checks to see if it's equal to 0 or not. If it's equal to 0, it's counted as a false. Non-zeros are treated as true. Do I recommend you do that? No, I would much rather you use the Bool Datatype, right? Something like this. Bool, I don't even know what I'd call it, so I'm just going to call it B for now. And then I would say B is equal to something. And then if B, then do something. So this would be some logical expression that gives you a Boolean value. But if statements will also work on integers. They might even work on floats. We could test that out. But if that's the case, again, 0 would mean false. Non-zero would be true. So the way they work, if it is raining, take an umbrella. If it's cold, wear a coat. So raining equals true. If raining, see out, wear a coat. Like that. Raining in this case is a Boolean variable, and a Boolean value that triggers a later action is known as a flag. So rain is a bool, and since it triggers an action, it is a flag. Is it cold outside? Yeah, wear a coat. Is it cold outside? Wear a coat, wear a hat, wear gloves. All right, we have a sequence of things inside the body subordinate to the if statement. So, if raining, let's do all three of them. See out, wear a coat, and I'm going to save time by copying and pasting. Copy that, paste, paste. If you're entering this code, I'm not entering it into Visual Studio. Wear a hat and wear gloves. There. So we have a body of code that's subordinate to the if statement. That body is only executed if this condition is true or non-zero. So, if statement notes, do not put a semicolon after the expression. This would break it. If we added that, then it would always print wear a coat, wear a hat, wear gloves, no matter what. Now why would that be? Because it is treated like this, like it's an empty block of code. It's treated like that. You can put a semicolon there or not. In other words, if it's raining, do nothing. And then, oh, by the way, go and do these three things as well. So you totally break your if statement if you put a semicolon after it. Quite often you'll get a syntax error, but in this case, no. You wouldn't get a syntax error, it would just be a logical error. It would always print those three things regardless of whether it was raining or not. So don't do that. Your general rule of thumb is never put a semicolon in front of a curly brace. That's always a exercise that's in breaking your code. 99.99999 times out of 100 that will break your code. Create either a syntax error or a logical error. So be careful when testing floats and doubles for equality. Trying to find a good example. I never remember one off the fly. All right, maybe that won't work. Let's give it a shot. Floating point errors happen because floats, unlike integers, are not exact. They have a certain number of digits before the exponent. They have a certain number of digits as their exponent. But you cannot convert a binary fractional value, a base 10 fractional value into a binary fractional value and have it be precise 100% of the time. Just like if you divide 1 by 3, the answer is not precise. It's 0.333 repeated endlessly. But it can't not repeat endlessly, right? It can only have a certain number of digits of precision. So if you tried to rely on that and you were expecting it to equal exactly 1 over 3, then you could get into a situation where it would not compare accurately. So I'm just going to make it as usual. Console app, call it Lecture G. And I must have chosen the wrong one. I meant to create an empty project. All right. Grab my boilerplate, go on my usuals. And I hope this floating point error works. If not, we'll discuss handling it anyways. Alright, so float f. F is equal to 0.1 times 1.0 times 10. Now see out f. Now what should this equal? 0.1 times 1.0 times 10, it ought to equal 1. Let's see if it does. They're saying that in Java it does not. Okay, fine. I really wanted to find an example for C++, just for y'all to see. And I found them for Python and for Java in the past. here's our example. Microsoft's got one. Let's give this one a try. All right, so here I'm going to do float A is equal to 1.345, and then float B is equal to 1.123, and then if, okay, and then F is equal to A plus B, and then let's see. Now if we add these up together ourselves with a calculator or something, then 1.123 plus that is equal to, I'm going to throw a fit if this doesn't match exactly. So if F is equal to 1.345, oh, that's not right. 2.468. So if F is exactly equal to 2.468, then Cout equals, Cout quote equals backslash n end quote.
Or can you zoom in?
Yeah, sorry. Here we go. Else Cout arrow arrow not equals backslash n. And I'm going to remove that extraneous pair of braces. And I'm going to see if Microsoft's example of a floating point error triggers. Okay, there it says not equals. But if we add it up in our mind, 5 plus 3 is an 8, 4 plus 2 is a 6, 3 plus 1 is a 4, and 1 and 1 is equal to 2. Looks like they're equal. But as far as it's concerned, they are not. And we can prove that by subtracting one from the other. So I'm going to say double delta is equal to F minus that value, 2.468, because that's our actual value. F minus 2.468. And then let's print out the difference. Delta is equal to, end quote, arrow, arrow, delta, arrow, arrow, indio. So when I run it, we're going to find out. Let me zoom, make this a little bit larger. I wish I kept this between sessions. That the difference between the expected value of 2.468 and the actual calculated value, it's a very small difference. It's point followed by 7 zeros followed by 6489, but it's a difference. So if you're doing comparisons between two floating point numbers, you should not just use equal equal. What you should do is you should take the difference between them and then see if they're within an acceptable error. So what we would do instead is this. If delta, or maybe even the absolute value of delta, do we have ABS available to us, or are we going to, yeah. If ABS delta is less than 0.000001, then let's see out, but close enough. Backslash n, end quote. I don't even have to store this value in a variable in order to get that ABS to work. So I'm going to make one more change to it to get that to work. What I would do is the two values that I want to compare would go in here. And F minus my actual value, 2.468, that's what I need. I'm going to delete these two lines. I guess I'll leave them there. Okay. So, they're not the same, but they're close enough. They're within 1/1,000,000th of each other. So that's close enough. I recommend that you consider that whenever you're comparing two floating point values for equality. For less than or greater than, it's not such a big deal. But if you're trying to check to see if they're exactly equal, floating point numbers are not precise. The conversion from base 10 to base 2 is not concise, not precise. And so after some floating point math happens, then some accumulated floating point errors can happen where this would not equal exactly what we thought it did. There's a small difference between the two, but we compare them to an acceptable error, and if they fall within that range, then we can go ahead and do it. So this is all they say about it, and I had to lecture about 10 minutes for it. I wish they'd given an example. Be careful testing floats and doubles for equality. All right, expanding the if statement. To execute more than one statement, you just use braces, right? Because if you're only putting one line of code, you don't need the braces. I think it's a good idea anyways, but sometimes to save space on my screen, since we're typing stuff in, I leave out the braces. But if it's more than one line, you have to put a block of code. Then else, two possible paths of execution rather than one. If raining, take umbrella. Else, leave umbrella home. So the syntax, of course, is if expression, statement, else statement 2. And the expression can either be a Boolean or it can be a number where non-zero equals true and 0 equals false. And I believe our textbooks last semester called this a dual alternative if, right? Is that number mod 2 equal to 0? That means that it's even if that is true, and it's false if it's not true. And so what you would do is you would write if. You would put that expression in there. And then inside braces you put print even. And then else print odd. Nested if statements. You can put one if statement inside another. You can test more than one condition. Goodbye, boilerplate. So, you have two variables, Boolean sick and Boolean tired. And you decide if you're sick, if you're running a fever. So sick is equal to temperature greater than 98.6. And tired is equal to sleep less than 8. You slept less than 8 hours. Then you could write a statement, if sick, and then you could nest one. If tired, then you can nest another one. Then we could see out, you are sick and tired. Stay home. Now, there's something silly about that logic, which is that maybe we want to let them stay home if they're sick but not tired. I don't know. You got measles, but you're not sick enough with the measles yet that you don't feel tired, right? You're sneezing and you're communicable, but you feel great otherwise. You still got to stay home. You've been exposed to something and you're a carrier, but you're not, expressing the symptoms. Whatever. So we might not want to write it like that. But we have a nested if, and that would work. If this condition is true and this condition is true, then we would print that out. There's another way of doing that same expression, and that's just to use and. If sick and tired, then see out, you are sick and tired, stay home, like that. I'd rather do this than this, unless there's just some strict absolute need to nest some ifs, because if you can express something with an and rather than with nested ifs, I think it's easier to understand once you get the idea that ampersand is the same as and. Now here's our example. Are you employed? I swear. Have I given this one recently? True or false? And are you a recent grad? True or false? Now if you're not employed, we yell at them and say you must be employed to qualify. So yeah, if they are employed, we have another if statement. If recent grad equals Y. If that's true, display you qualify. Otherwise, we display you must have graduated from college in the past 2 years to qualify. So, if employed equals true, and then a nested if recent grad equals true, then see out congrats, special rate. And I believe they had some else clauses here. You must have graduated from college in the past 2 years is one else, and then display you must be employed to qualify is another else. So I'm going to stick an else here. Else, see out, sorry, not recent grad. And then after here, else, see out, you must be employed first. I'm pretty sure I spelled employed wrong up here. Okay. So that is that flow chart expressed as code pretty much. Would I do it differently? Yeah, I probably would. I would, again, use an and. Whenever you see nested ifs, think to yourself, can this be simplified with an and? So I would do if employed and recent grad, then I'd print out congrats, special rate. I should have just cut and pasted it. Congrats, special rate. Else, and I would need one generic error message rather than both of these. See out, must be employed, and a recent grad. Sorry. Okay. I like that logic, personally, a lot better than I like this one. Don't know if you agree? I do. What's the drawback of this one is that in this case we give them a specific error message. We tell them exactly what's wrong. Sorry, not recent grad. Or you must be employed first. But on the other hand, I like this one because it tells them the exact ones that they have to meet, right? Because if they hear you must be employed first, this doesn't even mention whether they're a graduate or not, right? So they may take the test and they may not realize that if they had been a grad, then that you needed two conditions. So I would rather have expressed it like that. This would work as well. And we could nest all sorts of things inside all sorts of other things. But if our logic involves multiple expressions, and we can simplify it with an and, as I think that is simpler, then feel free to do so. I encourage it.
When you do the if statements, are we supposed to use the curly brackets or?
It's optional if it's only one line of code. It's mandatory if it's more than one line of code. So you can either do this, if condition statement, or if condition brace statement. If you leave off this like that, you won't get a syntax error. In Python, that would have worked great, but the way that it treats it, the compiler treats it as like that. So that one will be conditional, but these two will always get triggered, no matter what. So we do have to use the braces when we have more than one statement, regardless of whether it would cause a syntax error or not. Very, very good question. So could I have simplified this by leaving off some stuff? Yeah, I could have done that and done that. Looks good to me. Here, it's getting a little bit iffier, but I could have gotten rid of that. I could have gotten rid of that, and that, and that. And I'm going to wish I hadn't made all these changes. But anyways, that is valid code, but it's harder to read, maybe. If you've got Python experience, you're all pumped up and ready to do that. That works. And you may think, well, you just said that if you have multiple statements, you needed braces. Well, this is just one statement right here. It's an if statement. And it's got that, and it's got that, but that's all part of the if statement. This is all stuff that's subordinate to that. So that would work, but I think it's really messy. At the very least, I would do it like that. And as a matter of fact, usually I recommend using braces even for single lines of code. But if I'm typing stuff on here, I might be tempted to skip the braces for single lines of code just because I can put more text on the screen for y'all to see. That make sense?
Yeah.
Okay. She's yelling at us. Use proper indentation. I think I mentioned this, but if you get messed up, your indentation levels are off because you've been copying and pasting and stuff like that, you can ask it to fix it for you. You might not like the results, but it's worth at least giving a shot. What you do is you highlight everything, and I know I have to demonstrate this. Edit, Advanced, Format Document, and maybe it'll make it look good. In this case, it did a pretty good job. It may have removed some of my braces. Oh, here's something I don't like. Did I just make that change? Did I move that up there? Well, it left it like that. I would rather it have put that down there. Okay, so it can't fix everything. But it can fix the large problems, the tabs being off. Strongly recommend that. I mean, I'm not going to count you off if you give me code that's mistabbed. And if you've done Python programming, you're probably trained so well in making sure that your tabs work that you're used to it. But please, line up your tabs appropriately with your braces. All right, if, else, if. Test a series of conditions until one is found to be true. If it is raining, take an umbrella. Else if it's windy, take a hat. Else if it's sunny, take sunglasses. Whatever, that kind of thing. Python called them elifs. This language, you actually have to use the word else if. So, if expression, do statement 1. Else, if expression, do statement 2. And you can keep going. Now here's something you could do that I don't recommend, and I don't see any reason for it. If, exp1, do statement 1, else, and then put some braces, if expression 2, then do statement 2, else, maybe you see where I'm going with this, if expression 3, statement 3, else, statement 4. That has made it way harder to read than it should be. It's valid, but it's way harder to read than it should be. Here's what it should be. I'm just going to copy and paste all that and make the fixes to it. If expression 1, statement 1, else if expression 2, statement 2, else if expression 3, statement 3, else expression statement 4. Right? Because we could have kept indenting forever, right? Like that. You don't need to do that. Don't feel compelled to block off your else's if you can use an else if instead. Now maybe sometimes you got to do that, right? Maybe sometimes you have to nest it. But if you can create a chain of else ifs, whereas previously you had some nested else ifs, or nested ifs inside of else's, I encourage you to do it that way. This is something that's known as an if cascade. A cascade is a waterfall. That makes this effectively an if cascade as well, even though it's not tabbed that way. Cleans up your logic. On the other hand, if you're going to flowchart it, when you flowchart it, it's going to look like this. It's just a fact that flowcharting was invented before programming languages, actually. So, the good old grade score program. If test score is greater than A, print you made an A. Else if test score is greater than B, you made a B. Else if test score is greater than C, your grade is a C. else if test score is greater than D, your grade is a D. Somebody tell me, have we written this program yet in any of our homework or in class? The grade program. Okay. Whenever you write a series of ifs, if, else, ifs, you should have a trailing else to catch, even if you think that there's no other alternative. Even if you think your series of if, else, ifs handle everything, throw in one final else and just make it say, you know, invalid data or unexpected state or something like that. Because if we made some kind of mistake in this logic here, but we didn't have a final else to display the fact that that could happen, then you'd have a silent error where it didn't do any of these things and we didn't know why. Check some. No grade score program. That's going to be our next homework. I know you Java folks have done this program. Alrighty, so I may have y'all do this. Apologies to the Java folks who have already done it. Let's write a little program that will ask the user for a value, and then it will display some output based on that value along with if, else, ifs. And specifically, I'm going to use a value known as the BMI, which stands for body mass index. And it's just a ratio of weight divided by height, and if it's greater than a certain number, then you say, okay, you might be overweight. And if it's less than a certain number, you say you might be underweight. And as far as specific people go, it's not a very good metric, because muscular people wind up being classified as overweight according to this formula. It doesn't matter. You could have zero body fat and still be overweight according to that. But as a statistical measure, it is a useful one. So there's a formula for it. But instead, we're just going to see out what is the BMI to check, question mark. We're not going to even explain what BMI is. All right. And then I'm going to get my values, I'm going to check out if or BMI and go and find an image, and I should find something that tells me. Well, I guess I'm going to make some up because that doesn't do it exactly what I want. Here's a different one. Less than 18 is underweight. Up to 25 is normal. 25 to 29 is overweight. And then 30 is, we're going to change it a little bit to make it a little less pejorative. Okay. So, let's create a variable to hold the BMI, double BMI. And then BMI is, let's do an if statement. If BMI is greater than 30, we're going to print out that's a bit chubby. Else, else if, and why don't I take those braces away so I can put more code on the screen at the same time. Else if BMI is less than 18, see out, that's pretty thin. Else, a final else, I'm going to write this in the form that hopefully will produce an error, and I'm having to think about this. Else if BMI is greater than 18, and BMI, I'm making this too complex is actually what I'm doing. And BMI is less than 30, then C out, that's about average. I forgot to put ENDLs, so I'm going to put a final ENDL down here at the bottom. Okay, there's actually a logical error in this, and that's intentional. We're going to correct it before we're done. When you're writing if statements, checking for ranges like that is kind of problematic, especially for chaining them as part of an if cascade. Let me run this and make sure it's not a syntax error. There is, alrighty. Initializing double to float. Well, those are warnings though. Uninitialized BMI variable used. I forgot to write a CIN to read into BMI after I asked them. So down here, after I declare BMI, but before my if statement, it needs to be CIN arrow BMI. All right, so when I run it, what is the BMI to check? Okay, I'm going to say that I have a BMI of 32, and it's going to say that's a bit chubby. Now I'm going to run it again. My BMI is 17. I'm a fashion supermodel. That's pretty thin. All right, I'm going to run it once more. All right, what if my BMI is 24? That's about average. Okay, and then I think to myself, yay, I've checked it enough. I'm done. Can anybody, can you guess what error, what BMI is going to trigger the error that I'm expecting to see, which is it's not going to provide any output whatsoever. There's one value that would give me that. Not. Well, let's try it. You may be right.
Yeah.
Bingo, there's two of them. 18 would also do the trick.
Not equal.
Okay, so yeah, because I'm not checking greater than or equal. That's why I should have had some kind unexpected results. Yell at programmer.
Why would you encourage the user to yell at you?
Yeah, I'm making a joke. We would not put that in production code. Okay, so anyways,
Even as a joke.
now if I type in 18, unexpected results, yell at programmer. So anyways, we should put in something more informative, but it's a state that the program should never get into. It's a logical error. It's easy enough to fix, which is just to change this to else. And if we only have 3 states, chubby, thin, or average, then if I fix this like that, then I don't even need the trailing else. So if you have 3 states, if you can write your final one as just a trailing else rather than checking a range or whatever, then your code's going to be far more bulletproof. If you can't have a trailing else in order to get to your 3 states, then put one there that just prints out that it's an invalid state. And yes, we could have monkeyed with the comparison to get it to work, but there's no need to, because now it does work. Of course, we could argue about whether 30 or 18 is supposed to be, but whatever. Yeah, 30 is about average. Probably should have made it greater than equal to 30, right? I'm going to do that. And in fact, I'm going to structure the whole thing a little bit differently. So else if BMI is greater than or equal to 18, C out, that's about average. And then finally, one last else. That's pretty thin. Now we have some magic numbers in here. 30 and 18 are magic numbers that we probably should have not defined as magic numbers. And instead, we should have made them variables so that later on, if we decide to get more strict and make BMI of 25 chubby, then we could do that. So what we might want to do is to declare a couple of variables to do that. we might want to make them const. So const int overweight equals 30, comma, average equals 18. Something like that. Define our thresholds like that. And then replace the 30 with overweight, and then replace the 18 with the word average. And I lost my parentheses, so I'm getting a syntax error. All right. Now that code's not too bad. The real BMI table has 2 categories of overweight. I mean, whatever, you know. I think that'll prove the point, and I think you could see how this could be, the same concept could work on a grade program. Enter your score, and then, you know, print out whether it was an A, B, C, D, or F. So that's going to be your homework, and for you guys who've done the Java program, you could probably just take your logic and paste it and change the prints to couts, you know, and be done with it, and that's okay. Tell you what, I'm going to skip that assignment because they give you the answer right there on this slide. Right? So, what you would need to do is you would need to set up variables for A score, B score, C score, D score, and you would set A score equal to 90, B score equal to 80, C score equal to 70, D score equal to 60, and then using this logic it would print out whether you made an A, B, C, D, or below an F. I would love to know why E's are not acceptable scores, right? How did they come up with A, B, C, D, or F? Where did E go? So flags. A flag is a value that controls a condition, that signals a condition and triggers a later if statement. Usually implemented as a bool, but back in the olden days, in the C language, they didn't have bools, and so they used integers. And they would set the integer to 0 to be false, and any non-zero value would be true. And the if statement still supports that. But we have a bool keyword available to us in this, just like every other modern language, and so we may as well use it. Logical operators. Logical operators are ands and ors, and also not. And means both sides of the expression have to be true before the result is true. Or means one side or the other has to be true. And so let's make up some truth tables for both of these things. So here's the and truth table. If we have this expression, x and y, and then we want to know what the result is. Well, we have several different values. I'm going to use zeros for false. No, I'm going to use false and false. False, false, true is false. I'm just kind of talking to myself as I write this out. So what does this mean? The only time the result is true is if both x and y are true. And means that both operands have to be true for the result to be true. My classic example, if you have money and are hungry, go out to eat, else stay home. So that's an and. If you don't have money, you're not going to go out to eat unless you can mooch off somebody else. If you're not hungry, why bother? So both of these are necessary. You know, so if hungry and money, see out, go out to eat. An or truth table. For ors, they trigger as true if one or the other one is true. They don't both have to be. So x or, whoopsie, what did that come from? X or y, not sure why I switched uppercase, result. So you can have false, false, and the result is false. False, true, results in a true. true and false results in a true, and true results in a true. So if either side, or both, is set to true, then the result is true. So if sick or tired, stay home, else go to work. Like that. You can stay home if you're sick, you can stay home if you're tired. Either one. So something to notice is that if, wait, I made a mistake here. When I was typing all this in, does anybody see the mistake? You Java folks ought to instantly see it.
The third one.
The third one is wrong, right? Because and is true only when both operands are true. That should have been a false. So the only time and is true is when both operands are true. The only time or is false is when both operands are false. And if you took this little table and replaced those zeros, those F's with zeros and those T's with ones, like this, this makes it look like a mathematical operation. Makes it look like multiply. If we had a multiplication symbol here, the table is correct. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is 1. So, guess what? If we did the same thing with OR, then instead of multiplication, it's going to be addition. And there's actually a reason for showing that, because if I can trigger that in your mind, then you'll know the order of precedence. We've talked about order of precedence for arithmetic operators, but logical ones have order of precedence as well. So here we go. 0 plus 0 is 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, well, we live in a universe where you only have two possible values. True and not true. So it's not that 1 plus 1 equals 2. It's just that 1 plus 1 is not 0, so it's a 1. So we could say that logically, OR is logical addition. And if you ever go to take a four-year school's logic class, or maybe they even do this in discrete math, use some function. There's a word that I'm looking for, and it totally create expressions using addition and multiplication to create logical expressions. And so logically, OR is logical addition and is logical multiplication. That implies something about order of operations. If you're doing additions and you're doing multiplications like this, which one do you do first? You do the multiplication first. So if you have that, well, ands are akin to multiplication. So you have to do that one first, or I shouldn't say you have to. To do it the way the computer does it, you would evaluate that first, and then you would take the result and OR it against A. So that is treated like 1 plus parentheses 2 times 3. And this is treated like A or B and C. Like that. And then there's not. If you have not X, and then you want a result, well, the not of false is true, and the not of true is false. And I hope it's not messing you up that I'm just doing variables rather than expressions for these things, right? Because if A is more concise to write than if X is less than 10, something like that. But each variable could be replaced by a logical expression in these things, which is why I wrote, if we did if sick and tired, what if we redid it a little bit like this? Or let's use temperatures now. Temperature, and we're going to say 32 is freezing and 212 is boiling. So temperature F. We could ask for the temperature in F. In fact, let's go ahead and put this in our code. And you people from metric lands think Americans are absurd with your... Anyways, don't blame you. C out, arrow, arrow. What is the temperature in F? CIN, well, we need a temperature variable to store it in. So double TMPF, and then CIN, arrow, arrow, to temp F. So let's check inside the range. To check within a range, you can use AND. To check outside of a range, you use OR. So if temperature F is greater than 32 and temperature of F is less than 212, C out, it's liquid, \n. Now to check outside that range, we would use OR. If temperature F is less than or equal to 32, or temperature F is greater than or equal to 212, then C out, it's not liquid. And yeah, of course, we could have just tacked on an else, right, and then not done a second comparison. But what I'm trying to show you is that you can check to see if something is within a range or something is outside of a range. If you're checking to see if it's in a range, you link them with ANDs. It has to be greater than 32 and it has to be less than another value. If you're checking outside of a range, you use an OR. If the temperature is less than a certain value or it's greater than another value, it's outside of your range. My general advice is if you start using nots and not equals, see if you can rewrite the logic to get rid of them. And another thing that might make other programmers look askance at you, but I like it, is instead of saying not, if not F, writing instead if F is equal to false. Both of these do the exact same thing, but to me this one is easier to read. You want to do it that way, totally cool, and that's how the majority of programmers would go. But when I was first, if I'm blocking out logic first, I would rather write that out and then convert it to this later, if I so chose. And hopefully I've already said double ampersands is equal to AND, double bars is equal to OR, and exclamation mark is equal to not. And you may have heard of exclusive OR, but there's no logical exclusive OR operator in C++. There's a bitwise version, and I still need to knuckle down and give y'all a lecture on bits and binaries and hexadecimals and ASCIIs. So let's see if we can figure these out. X is equal to 12, Y is equal to 5, Z is equal to -4. So they've already used parentheses to cluster them correctly. Probably not necessary. I think we could type this entire expression without using these parentheses and it would evaluate appropriately because there's only one logical operator. But it makes it easier to read. So is X greater than Y?
Yes.
How about is Y greater than Z?
Yep.
So, is the result of this expression true or false?
True.
It's true because they're both true. How about this one? X is greater than Y and Z is greater than Y. Well, is Z greater than Y? It is not. So, we have a true and false, which is going to evaluate to
False.
false. Is x less than z?
No.
No, so that's a false. Is y equal to z?
No.
That's also false. So we have a false or false. So what's the result?
False.
False. Exactly. Is x less than z? No, we've already said that it's not because x is greater than z. Is y not equal to z?
Yes.
True.
And that's true. So we have a false or true, which is,
True.
yep, it's not false because or requires only one side or the other to be true. So the result would be true. And how about this? How do we figure it out? Well, we do the part in the parentheses first. Is x greater than z? It is. 12 is greater than 4, and then the not turns it into a false. And in my Fundamentals of Programming class, I give a worksheet with like 30 different expressions to do. It's kind of tedious. Not sure I'm going to make y'all do that. So here, they're combining that if logic into a single and, just like I illustrated. If employed equals y and recent grad equals to y, you qualify for the special rate. Else, you must be employed and have graduated recently. Pretty much anytime you have nested ifs, consider using and. Well, when would you use or? If you have multiple operations, multiple comparisons that give you the same value, like this. If x is greater than 100, C out, not a liquid, this time we're doing Celsius, else, or no, let's do if x is less than 0, C out, not a liquid, like that. That could easily be rewritten as if x is greater than 100 or x is less than 0, C out, not a liquid. That doesn't mean that you can replace if, else ifs. But if you have multiple ifs that give you the same result, use an or instead. And then if you have nested ifs, try to use and. So if, and I've already given that to you. If you're hungry, and then if you have money, go out to eat. As opposed to if hungry and money, go out to eat. Getting close to the end. All right, so not has the highest precedence, even higher than and. So not, followed by and, followed by or. And then there's something called short circuit evaluation. Short circuit makes it sound bad. The engines have short circuited. We're stuck in the water. But short circuiting doesn't mean bad at all in programming. It just means, and this will be the last thing that we do, we'll call it a day. If we have something like this, if hungry equals true, and I'm doing it old school, money equals true, then see out, go out to eat, go out to east. Once we have determined whether we're hungry or not, if we're not hungry, do we still need to check this? If this is false, is there any way that the entire expression will evaluate to true? Did I hear no?
Nope.
Nope. Right. So, when you're using an and, if the first operand evaluates to false, then the second evaluation is skipped. That's known as short circuiting because we took a shortcut. We didn't have to do that. Does that matter as far as your programming goes? It can. And if you're using OR, if sick is equal to true or tired is equal to true. If sick is equal to false, do we still have to check tired?
Yes.
We do have to, but what if sick is equal to true? Do we have to check tired? No, we don't have to because we've closed the case. If sick is equal to true, it doesn't matter what tired is. So when using AND, if the first expression evaluates to false, we skip the second one. When using OR, if the first expression is true, then the second evaluation is skipped. So 99.9999999% of the time, the program is going to work regardless of which one you put first and which one you put second. But there is a consequence in the order that you choose. And especially since you're programming in C++ and not a slow language like Java and Python, it's worth considering performance. And if you have to check both things, say this check took a second and this check took a second, and you had to check them both every time, and you had 100 things to check, this was repeated 100 times, that would take 200 seconds total. But by short-circuiting, we can conserve some time, right? And if this was false here on the AND, then it doesn't have to check that one. So sometimes the expression only takes 1 second to evaluate rather than true. That means that you want to rule as much stuff out as possible. You want the second evaluation to be skipped as often as possible. And the way you do that is you put the more common one first. I'm hungry a lot of the time, so I'm going to rule that out first. On the rare occasions, I think I've worded that backwards. You probably got where I was going before I actually gave this one. You want to put the thing that's going to evaluate to false more often than this one. So, I'm hungry all the time, but I rarely have money. If that's the case, I should put this check first and this check here second. Because if I can rule it out, for a majority of the cases, it only takes 1 second to do it rather than 2. And OR is opposite, right? If I'm sick a lot, I want to put the one that causes the evaluation to be skipped first. And if I'm sick more often than I'm tired, then I would want to put it first. But if I'm tired more often than I'm sick, I would want to put the tired expression first. That helps performance. The other time that you have to care about short-circuiting or not is if you're modifying the values of the variables in the comparison. If you do x plus plus greater than 10 and y plus plus is not equal to 0, whatever it was, it would evaluate this expression first. And if that was false, it would never do this one. Y's value would never get changed at all. Now, do I recommend you write code like this where you are changing the values of the variables as you're comparing them? Well, it's okay if it's the only thing you're doing in it, but if it's a complex expression with ands and ors, absolutely not. I would not do that. Instead, I would increment them both beforehand. So this is bad because y plus plus might not happen. And to redo it, you would increment x, you would increment y, and then you would do your calculation if x is greater than 10 and y is not equal to 0. That's if you want both of them to happen. If you always want to be adding 1 to x and 1 to y, then you better write it like that rather than that. All right, that's about enough. Let's stop this, stop this, stop this. don't see a homework assignment that I want to give you, so I'm going to write one. Write a program that will ask the user for their height in inches, their weight in pounds, and then calculate their BMI, body mass index. The formula is BMI is equal to 703 times pounds divided by, pounds divided by inches times inches, like that, or POW inches too. Then print the same message as we did in class. Print the, you might be underweight, your average, or yeah, just the three categories. Based on the values, less than 18 is underweight, 18 to 25 is average, and greater than or equal to 25 is overweight. And like I said, those numbers are not really applicable to specific circumstances. This 25 in particular gets argued about. So a lot of people will say 30 means obese rather than 25, but anyways, okay, that makes sense. All you're doing is this part. That makes it pretty easy. You're going to ask for two values, you're going to perform the calculation, print the results, and then print the little thing that we did the if statements for today. Does that make sense, guys? I think so. That one ought to be pretty easy. I can't think of anything else to do to make it really cool, so why don't we end it at that one? About the only thing left to cover in this chapter will be switch statements. So we're going to be done with this chapter remarkably soon, which means that putting the final off 2 weeks is kind of absurd. Let's change the date of the final to move it up one day. So, and if you can't make a test, just remember that you can take it down at the testing center, but they won't let you use an e-book. So, because I do let you use your books in classes. So we're going to make the final on, not the final, the exam on the 25th.
Didn't you just say it was the 27th?
Pardon me?
Isn't it 27th?
Well, I'm changing it, unless you've seen a reference to it.
Yeah, the notice you just sent out.
Right, I posted a notice, and I'm modifying the notice because we are done with chapter 4 as of like 10 minutes into the class this Thursday. Nope, you're absolutely right. Unless there's a strong reason, if anybody needs it to have been 27th.
Just for the fun of it.
Pardon me?
Give us 2 extra days just for the fun of it.
Nah, you don't want the extra days. That'll just be days you sweat and panic. My exams are not terribly hard. You do get to use your notes. You do get to use your book. You do get to raise your hand and ask me questions. We'll have a review. This is the real reason to set it on a Tuesday rather than a Thursday. Because if it's on a Thursday, I do the review on Tuesday, and you only have 2 days, advantage. But if it's on a Tuesday, I do the review on Thursday, and so you have, the entire weekend if you care.
So we're taking it in class or at the test center?
This is in class, but if you can't be there that day, you take it at the test center.
Can you describe what the format of the exam is?
Multiple choice, true falses, selection, match A and B and C and stuff like that, and a few snippets of coding. So do the reviews for chapters 2, 3, and 4, and that'll give you a real strong idea of the format of the exams.